Hello everyone, my post number is 403. The title is Mapping Present Vertical Crustal Deformation over Weihe Basin China using S1 and Alos2 scans imagery. Weihe Basin, located in central China, is in the north of the Weihe uplift belt of Ordos Block, south of the North Qinling Organic Belt, west of the southwestern margin of the Ordos Orc Structure Belt, and east of the Shanxi Uplift Belt, which is spanning 350 kilometers from east to west. The basin is an important component of the well-known Feifei seismic belt. Hundreds of faults have been found in the basin, and the fault structure is crisscrossed. A MS-8 earthquake occurred in Xi'an County in 1556. Since 1177, there have been more than 25 times MS-5 earthquakes. However, there was no earthquakes greater than MS 5.5 since the 20th century. In order to understand the structure and the slip risks of the known fault zone in the Weihe Basin, identify potential active faults and their activity levels in the Weihe Basin, and overcome the shortcoming of existing GPS and leveling data. We first use 92 scans ascending S1 and 6 scans descending Alos2 scans datasets to acquire the LOS deformation velocity, respectively. StarMPS is used for S1 data processing, and the stacking method is used for Alos2 scans. Both in the S1 and Alos2 scans processing, SRTM-DM is corrected by geode offset between EGM 96 datum and WGS 84 datum, and Gecko's atmospheric products are also used to reduce the error of the tropospheric delay. And then vertical and west-east deformation velocity are calculated over the entire Weihe Basin based on S1 and Alos2 scans with each varied look vectors. And the previous of inside vertical deformation is around 2 mm years compared with leveling data. Some active actors and ground fissure are successfully detected. The special temporal characteristics of the talent oblique force disciplines and basin, some distance are quantitative modeling with inside technical ranging from uplift 10 mm to subside 140 mm per year. Our velocity field indicates the complex of the internal motion in Weihe Basin controlled by multiple forces with different deformation patterns. Finally, a slip distribution in motion is calculated based on the multi-fault in interseismic mode, the block degree, and the relationship of earthquakes, and are discussed by western section of northern Qinling Fault, the Gaojiacun Gaodian Fault, the western section of the Weihe Fault, the section of the Baoji Fault, the Tianxian Fault, the western Liquan Pucheng Heyang Fault, and the middle Longxian Mazhao of the fault. In our study, the precision of inside vertical deformation is here around 2 mm per year. Inside results help us to detect the buried active force. Weihe Basin were controlled by multiple forces with different deformation patterns. Active force in the western of the Weihe Basin show obvious creep characteristics. Thanks.